mistaking if it's
Should be good.
Okay, cool.
Okay, so I've been given permission to push everything back 10 minutes. That actually fits in with when lunch is scheduled. So we'll end this session at 12:30.
Okay.
So I'm delighted to introduce Professor Walsh from the University of Nottingham, addressing the question, how many colours?
Oh, I didn't know I was supposed to run that one. All right, thanks. So I realized kind of in hindsight after I sent my title to Maria that this wasn't probably the most helpful of titles to have at a conference like this. And so I think in hindsight I would have maybe added a colon and done a subtitle, something like Disagreeing with Newton or something, because what I'm talking about today is a debate or a disagreement that occurred between Newton and a couple of other philosophers, Robert Hooke and Christian Huygens. This was a debate that happened in 1672, around when after Newton sent his first optical paper to the Royal Society. It's a particularly interesting debate for several reasons. We learn a lot about Newton's new methodology, Newton's theory of light and colours, and it's a really interesting debate in that they really press him on a lot of the important points. Okay, so here's what I'm going to do in this talk. There's going to be an introduction, which I've sort of basically already finished. Then I'm going to introduce Newton's new theory of light and colours. I'm going to give you the outline on that. Basically, I'm going to give you some of the key points of it. Newton introduces a new phenomenon of light, and from this, he uses this to develop a new theory of colour. And I'm going to look at two of the people who disagreed with Newton about this. So Robert Hooke raised a bunch of objections to Newton, and so did Huygens, and Newton responded to these. And then I haven't really thought about disagreement very much, to be really honest. I've looked at this debate for a whole lot of other reasons to do with trying to understand Newton's methodology and so on. And so, based on some ideas that I've been grabbing from the talks that I've heard over the last day and a bit, I'm going to reflect a little bit on this disagreement. Okay, so introduction done. Some things about Newton's new theory. So in 1672, Newton kind of appeared out of nowhere as far as the Royal Society was concerned. The mathematicians certainly knew who he was at this point, and he was the Lucasian Professor of Mathematics at Cambridge by this point. But the first that the Royal Society really ever heard about him was when he sent them his new reflecting telescope. And they were quite impressed by this, and Oldenburg, the secretary of the Royal Society, got in touch with him and said, but can you tell us some more stuff about what you're doing? And he sort of played coy for a bit, and then just all of a sudden sent this paper. I think Oldenburg had been expecting him to have stuff just to say about the development of telescopes. I don't think they ever expected that he had developed this whole theory of light and colour. The theory was kind of in equal parts, was received by the people at the time as sort of in equal parts ingenious and also kind of scandalous. Basically, he was rejecting the received view of light and colour. So on the received view, white light is homogeneous. This makes it kind of metaphysically maybe important because it's pure. And colours are the result of the modification of white light. So colours result from white light being, say, agitated or something when it's put through a prism, something like that. It's hard to kind of talk about one received view because at that time people basically had many, many different views, but these are roughly the things that everybody agreed on. And Newton rejected both aspects of this. And the problem was that nobody really thought that there was anything problematic about these things, and so this is why it was kind of scandalous. As one commentator on Newton, Zev Bechler, has put it, this is just simply not how things are done. You don't just walk in, conduct a revolution and walk out in one fell swoop. Nevertheless, the paper was very well received when they when they looked at it. So Oldenburg very quickly wrote back to Newton and said, "I can assure you, sir, that there it met with a singular attention and an uncommon applause, in so much that after they had ordered me to return to you their solemn and ample thanks in their name, which I herewith do most cheerfully. They voted unanimously that if you contradicted it not, this discourse should without delay be printed, there being no cause to apprehend that the ingenious and surprising notion therein contained, for such as they were taken to be, may easily be snatched from you. And so basically, this Oldenburg sent this letter to Newton sort of the day after they had received it at the Royal Society, and so it was published in the Philosophical Transactions basically a week later. So things moved very quickly back then, unlike today. Another thing unlike today is that Oldenburg, after agreeing to publish it, then went around and sort of tried to get some people to kind of review it or comment on it. And so, again, things sort of happened the other way around back then. Oldenburg got in touch with some of the optical heavyweights, so people like Christian Huygens, Robert Hooke. There was also a couple of others who actually didn't respond, but the Reverend Parties also commented on this. And so basically, Oldenburg was really important in, over the next several years, he kind of received letters and sent off letters to different people and acted kind of as the conduit for various people to debate with Newton on this topic. Okay, but let's move on to what the key features of this paper were. So first Newton Newton identified a new phenomenon of light. Okay, so he starts by describing this experiment. He kind of claims that he happened upon this new phenomenon kind of accidentally when he was playing around with some prisms, as people like to do. And so what he did was that he put the light, here's the sun, here's the sunlight coming in through an aperture in a window frame, it goes through a prism, and then it's projected onto a screen. What Newton noticed in carrying out this experiment, as he says, to his very great surprise, he discovered an elongated spectrum. On the received view of light, he should have expected a circular spectrum, so basically a spectrum that was the same shape as the aperture. There are various reasons why this is surprising, and why. I mean, it's kind of surprising actually that Newton was the first person to notice this. And there are basically two reasons why Newton was the first person to notice this. One of the things is that actually you should expect an elongated spectrum in most of the positions that this prism is going to be held. So if you tilt the prism or move it in any other way, you're going to get an elongated spectrum. But as you kind of quickly learn by reading this paper, Newton was holding the prism in exactly the one position, the position of minimum deviation, in which you wouldn't expect an elongation. So despite what he's saying about this being just a very pleasing, what does he call it, very pleasing divertisement, he kind of knows what he's doing. He's testing a theory. The other thing that he does is that where most people up until that point had tended to hold the screen very, very close to the prism, and so even if there was an elongation, they wouldn't really see it. Newton was holding the screen at a very, very great distance. In fact, that was 22 feet. So what he's doing is he's carrying out a very specific experiment, testing a very specific prediction, and he's aiming to get kind of the maximum effect that he possibly can, given the size of the room or whatever, to get that. Okay, so that's what he's doing. Another thing to notice is that in this first paper, Newton doesn't talk about colour at this point. He's interested in just the size and shape and position of that image on the far screen. And so he's interested in things like this, the position of the prism, the size and shape of the aperture, and so on. And so when he talks about this elongation, he's not talking about colour, he's talking about size and shape. Okay, so he runs through a whole bunch of, he kind of speculates about a bunch of different kinds of explanations we could give for this on the received view of light. So he wonders if maybe light doesn't travel actually in a straight line, maybe it kind of curves slightly after it goes through a prism. He sort of shows that this can't work. He even wonders if the different incident light from the different parts of the disk of the sun, maybe there's significant enough. Maybe there's a significant enough difference there to kind of cause the elongation. He ends up showing that can account for some of the effect, but not the full effect, and so on. And so after having ruled out a whole bunch of other hypotheses, he ends up carrying out this, what he calls his experimentum crucius. On this experiment, sun comes in through an aperture in the window, and then goes through the prism. He sets up a screen with an aperture in it where he takes just a small part of the spectrum through it, and a further one where he again just takes a small part of the spectrum through it, puts it through another prism, and projects it onto a far screen. Ideally, this experiment might look something like this, but probably not. It's a very difficult experiment to produce. And the idea is that if you move this prism slightly in different ways, you'll be able to send different parts of the spectrum through that aperture and onto the far screen. And so the idea is that if you're looking at it in terms of color, that you tend to isolate a certain color, and that gets pushed through. But of course, like I said, Newton doesn't talk about this experiment as involving color. He talks about this, so what he's interested in is the positions of the prisms, and the positions and sizes of the apertures, and the position, in particular, the position of this image on the far screen. And what he knows, and this is really hard to explain without talking about color, what he notices is that the bit of the spectrum which is at the lowest part at this point is going to land at the lowest part on the far screen. And if you send through the highest part of the spectrum here, then it's going to land higher on the far screen, is what he says. So he says this: "And I saw by the variation of those places that the light tending to that end of the image towards which the refraction of the first prism was made, did in the second prism suffer a refraction considerably greater than the light tending to the other end." Nearly incomprehensible. He basically invents this word refrangibility to explain what's going on here. Refrangibility is kind of the disposition of light, of any particular ray of light to refract to a certain degree. And so what he's really talking about here is the angles of incidence and refraction. So in this experiment, what is shown is that you get a certain angle of incidence here, and you get a certain angle of refraction there. And at the same angle of incidence over here, the ray will refract to the same angle over here. And this angle will vary depending on which part of the spectrum you put through. And so he concludes from this. See how hard it is to explain this without talking about color? So he says, "And so the true cause of the length of that image was detected to be no other than that light consists of rays differently refrangible, which, without any respect to a difference in their incidence, were according to their degrees of refrangibility transmitted to different parts of the wall." So what he's saying is that white light is a mixture of rays of different refrangibilities. Okay, so at this point, what he had done is he had established a new phenomenon, the elongation of the spectrum. And this had led him to infer, via the experimentum crucius, a new property of light. Heterogeneous, that the light is a heterogeneous mixture of rays of different refrangibility. And so he had refuted the idea that white light is homogeneous. Let's check how much time I've got. Okay. So now moving on to the new theory of color, because this had implications for how we think about color. Okay, so this is the argument that he makes roughly. He's established that white light is composed of rays of many refrangibilities. Then he establishes that there's a one-to-one correspondence between refrangibility and spectral color. So for any given ray of light, it's going to have a certain refrangibility, a disposition to refract, and it's going to have a certain color to it. And from these two things, he was able to infer that white light is composed of rays of many spectral colors. And so this allowed him to develop a color theory. He does this in 13 propositions, but I'm just going to kind of give you the highlights, the things that kind of become important through the debate. So the first thing is that he thinks that there are two kinds of color. There's original color and compound color. So original color is the kind of, is an inherent property of any particular ray of light. So the way that you might identify original color is that it's going to be unchangeable. If you've got original color and you're putting it through a prism, then you're going to end up with that same color coming out the other side of the prism. Compound color, on the other hand, is color that might look the same color as original color, but when you put it through a prism, you can divide it into its two components, or into its many components, and so on. So what he's done is he's kind of identified this new property of light, that color is a property of light, and you can distinguish between original and compound light by what comes out the other side of the prism, or you can break it down into its parts. The second feature that's important here, that color and refrangibility are inherent and immutable properties of light. So the thought is that you can't change the refrangibility of a particular ray of light, and you can't change its original color. And this helps us to understand a feature that I think a lot of people misunderstood about Newton's theory of color at this point. Some people thought that Newton thought that the refrangibility kind of causes the light to become a certain color, and so on. But the only kind of way in which refrangibility causes color is that it allows the rays to sort of separate into their component parts. So because of the different refrangibility, we're able to separate out the rays into their different colors. But Newton's idea is that color and refrangibility are both properties of light. And so in this sense, white light is unique in that it's the only kind of color of light that there is no original color of that kind, or there's no original rays of that kind. So white light is the only kind of color that can be produced by combination and not by not by kind of isolation. Okay, and then the third thing is that he argues repeatedly that there's an indefinite number of colors. To be very clear here, he's making an epistemic point here rather than a metaphysical one. He thinks that it's indefinite in that the number, in that they're uncounted. There's an uncounted number of colors. And the reason why he thinks that it's this way is because he's really thinking about light as kind of being, don't want to say the word corpuscular. He's thinking about light being a substance, though. He thinks about rays as being kind of divisible things. And so in principle, you should be able to count the number of colors. So it's sort of uncounted rather than uncountable is the way he puts it. And he also kind of says that there are 7 colors, but what he says is that there's sort of 7 main colors, but there's also an indefinite number of degrees in between those 7. So that's the answer to the title of the slide at this point. Okay. All right, and then just one other thing that he sort of tries to be clear on, and this actually comes up more in the optics when he talks about this. He's very careful about the nature in which light has a color. So he says that if at any time I speak of light and rays as coloured or endued with colours, I would be understood to speak not philosophically and properly, but grossly and accordingly to such conceptions as vulgar people, in seeing all these experiments, would be apt to frame. For the rays to speak properly are not coloured. In them there is nothing else than a certain power and disposition to stir up a sensation of this or that colour. So when he's speaking kind of fully and philosophically, as he puts it, he talks about red making rays and yellow making rays and so on, rather than red rays. All right, so now let's move on to the disagreements. A couple of things to say first up about these disagreements is that what's interesting about these disagreements is that this is not a theological dispute. So it's not the kind of thing that we see earlier when, say, between Galileo and all of his opponents. It's not the kind of thing that we see later between Newton, with Clarke as his mouthpiece, and Leibniz on the position of God in the world. It's not even a dispute over kind of worldviews in any important sense. It really is. I've got more slides. It's also not a priority dispute. So again, it's not the kind of dispute that again we see between Newton and Leibniz, or even the kind of priority dispute that we see between Newton and Hooke later on. And it's not a dispute between, say, opposing camps. It's not like this is kind of becomes a continental versus British divide, or a rationalist versus empiricist divide, or even an experimental philosopher versus speculative philosopher divide. These people are all kind of, in most respects, kind of on the same side here. And so first and foremost, it's a dispute about theories of light and colour. And I think this is really interesting. I suspect that this is kind of what are the first of this kinds of debates that we would see. We've got the very earliest sort of scientific papers being written around this time and being published. And really they're kind of inventing this genre of empirical dispute around this time. So I think these are some of the interesting things about this case. Okay, and so the kinds of questions that they're raising and asking each other are things like this. Could the received view explain the elongation? Sorry, there's a typo there. Was the experimentum crucius in fact a crucial experiment? What was the epistemic status of Newton's new theory? How many colours are there? And so on. These are the kinds of questions that they're raising. Okay, so now we'll look at some objections that Hooke raised. Okay, so Paul Robert Hooke, history has really not been kind to him. And so for a while people thought that this was him. This was the only known portrait of him in existence. It turns out to be Van Helmont, not him at all. There probably was a portrait of Hooke at some point. There are some reports of people going into the Royal Society and seeing a portrait of Hooke on the wall next to a portrait of Boyle. And hypocritically, Newton had the portrait of Boyle burned when he became president of the Royal Society. Now people think that's almost certainly not true. Nevertheless, there are no known portraits of Hooke. But there are some very good descriptions of what Hooke looked like. Actually, Hooke had this way of, in his diary every day, he kind of wrote how his appearance looked and things like that. So we've got that, and we've also got sort of from other people who had seen him and sort of describe him in various ways. And so there is an artist who has sort of taken to trying to produce portraits of Hooke. The aim being that she'll stop when there are more portraits of Hooke in existence than portraits of Newton. But anyway, so this is an artist representation of what Hooke may have looked like. Anyway. Okay, so I think this quote kind of captures Hooke's initial response to Newton on this topic. He says, "I do not therefore see any absolute necessity to believe his theory demonstrated, since I can assure Mr. Newton I cannot only solve all the phenomena of light and colours by the hypothesis I have formerly printed and now explicate them by, but by 2 or 3 other very differing from it, and from this which he hath described in his ingenious discourse." So what Hooke's basically saying here is that, sure, Newton may have kind of identified this new phenomenon, but that he can save it with his hypothesis and a whole bunch of others. One of the things that Newton really missed in the discourse with Hooke is that Hooke isn't just defending his own hypothesis, he's actually arguing that any one of a number of hypotheses could explain this, whereas most of Newton's responses to Hooke look as though Newton really thinks that Hooke's kind of defending his own view. Okay, so what I'm going to do is pick out just 2 of the key objections that Hooke raises, and we'll look at how those go. Okay, so the first objection that Hooke raises is that there are no original colours. So colour is not an inherent property of light. Okay, so here's what Hooke says. "But how certain soever I think myself of my hypothesis, which I did not take up by first trying some hundreds of experiments, yet I should be very glad to meet with one experimentum crucius from Mr. Newton that should divorce me from it. But it is not that which he so calls will do the turn. For the same phenomenon shall be saved by my hypothesis as well as by his without any manner of difficulty or straining." So basically he denies the fact that he rejects Newton's experimentum crucius as a crucial experiment. Interestingly, Hooke was one of the only people that could actually replicate the experiment. So it's not a matter of not being able to replicate it. Many other people objected to it because they were not getting the same results as Newton, but Hooke wasn't one of those people. He successfully replicated it. He just didn't think that it showed that colour is an original property of light. Okay, so we've seen the experimentum crucius and we've seen Newton's argument. Basically, the mistake that Hooke was making here was thinking that this was the result of the experimentum crucius, that white light is composed of rays of many spectral colours. So as far as Hooke was concerned, the experiment was designed to decide between 2 views on colour. The modificationist view, or a modificationist view, and the Newtonian view. And so here's how Hooke probably saw the experiment. It was an experiment in colour, not black and white. It wasn't about the geometrical properties of light. And so on Hooke's view, this is what's going on. You put white light, which is pure, through a prism. The prism kind of distorts and mixes up the light in some way, causes it to vibrate or something. And so that all these colors are produced out of it. And then you can kind of isolate one of those colors by putting it through an aperture in a screen. And the thing about that light, once that color has been produced, once the light has been kind of shaken up in some way so that it starts kind of looking different colors, it's not going to kind of go back to normal. It's not going to go back to white again. It's going to kind of hold that color as you put it through other prisms and so on, until you kind of do something to it to kind of stop it from having that disposition, and then it's going to go back to normal, is kind of how he thinks of it. And so it's easy to see why, on his view, this isn't actually supporting Newton's position, because all it does is support his view that, you know, once white light has been kind of shaken up somehow and caused to produce different colors, it's going to keep doing that until something else happens to stop it from doing that. Newton's response to this was to kind of try and resolve this, to try and find some empirical point on which they could agree. So some prediction, some empirical prediction that they could test to find out whose view was right. So he says, I shall now proceed to abstract the difficulties involved in Mr. Hooke's discourse, and without having regard to any hypotheses, consider them in general terms. They be reduced to these three queries. I'm going to just focus in on one of the queries right now. He says, whether the unequal refractions made without respect to any inequality of incidence be caused by the different refrangibility of several rays, or by the splitting, breaking, or dissipating of the same ray into diverging parts. So notice, Newton, nowhere in the correspondence with Hooke does Newton say, oh no, you've misunderstood, I don't think this experiment supports the view on colour, it's about refrangibility. He never says that. He just kind of blunders on and says, no, let's just keep talking about refrangibility. So this is what he does. He thinks that this is kind of the point at which they disagree. Okay, so on Newton's view, we saw that this is the proposition that Newton thinks this experimentum crucius supports, that white light is composed of rays of many refrangibilities. And so as far as Newton was concerned, the experiment was demonstrating a new effect. It's an effect that there was no received explanation for, and it was not about colour, as we said. So, as far as Newton was concerned, the experimentum crucius demonstrated that the elongation effect was not an artifact of the experimental setup, but due to an inherent property of light. Okay, so, right, and we've seen that this is how Newton saw it, and we can see why, on Newton's account, he really thinks that this experimentum crucius supports this. So you've got light coming in at some angle of incidence, and it's coming out at a different angle. And over here you've got it coming in at the same angle of incidence, and it's leaving at that same angle. Okay, so this is how he sees it. And what he sees is that it's bending here and it's bending here to the same degree. This has got to be a property that was already in the light, as far as he's concerned. So I think what this shows us is that for Newton, precise measurement was really important. What he's really trying to do here is sort of mathematize how we're going to think about light. He's interested in things like degrees and positions and shapes and sizes, things that we can kind of reason numerically about. And also it's kind of important that he wouldn't have been able to be this precise if he was thinking about colour. In fact, when he did try and kind of really nail down what kinds of colours were appearing and so on, in different spectrums, he had to get someone else to look at it for him because his eyesight was just not good enough at this point, probably from years of staring into the sun directly to see what colours were produced and so on. But he couldn't do this, whereas he could actually carry out these kinds of experiments. Right, and we also see that he's kind of reasoning mathematically from certain principles. So he sees that this is kind of a certain first principle that he has established experimentally, and from there he's able to reason without epistemic loss to this conclusion. Okay, so the second objection that Hooke raised was this one, that there are only two primary colours. So we already said that there are no original colours, so what Hooke means by a primary colour is something very different. He thinks that you only need two colours in order to kind of generate all the other colours by mixing them. So this is what Hooke says. But as to the fifth proposition, that there are an indefinite variety of primary or original colours, amongst which are yellow, green, violet, purple, orange, etc., and an indefinite number of intermediate gradations, I cannot assent thereunto as supposing it wholly useless to multiply entities without necessity, since I have elsewhere shown that all the varieties of colours in the world may be made by the help of two. Okay, so according to Hooke, many apparent differences in the colour of light were really differences in the amount of light. So he's kind of got this two-pronged account of how you generate colour. It's kind of some mixture of hue and also kind of light coming in underneath it, kind of amplifying it in certain ways. Okay, so the experiment that he describes on this is this one. So basically he took kind of vessels and he had kind of what he calls tincture of aloes in one of them, and what he noticed was that you kind of, in the center of it, it's kind of a reddish color, but then around the edges where the liquid is kind of there's more light coming through the glass, it looks yellower. And so he took that to mean that kind of really red and yellow were really just kind of one color. There's red, and then you add a bit more light to it and it becomes a bit more yellow. He also sort of took a copper solution, so a bluish solution, and again he noticed a similar thing where right in the middle of the vessel it's going to look blue, but around the edges it kind of took on an indigo or violet kind of color. And so again what you get is, so there's just one color, blue, and you add more light to it and it starts looking a different color. And what he sort of did was he played around with placing the two vessels in front of each other and shining more light through it, and he found that he could get the other colors. The other colors kind of appeared when you did that. Okay. And so Newton's second query was this, well, whether there be more than two sorts of colors. Newton's response to this is methodological rather than empirical. He says, now if Mr. Hooke contend that all the reds and yellows in the one liquor or the blues and indigos of the other are only various degrees and dilutings of the same color and not diverse colors, that is a begging of the question. Certainly it is much better to believe our senses informing us that red and yellow are different colours, and to make it a philosophical query, why the same liquor doth according to its various thickness appear of these different colours, than to suppose them to be the same colour because exhibited by the same liquor. And so basically he's kind of raising a methodological disagreement with Newton on this, with Hooke on this point. Okay, and just one final thing to say about these disagreements. This does kind of go back and forth a lot, but we need to move on. Hooke was not convinced by any of this. Nothing Newton said to him could convince him that Newton was right, and in fact, he kind of ends up writing this to Lord Brouncker later. I see no reason why Mr. Newton should make so confident a conclusion that he to whom he wrote did see how much it was besides the business in hand to dispute about hypotheses, for I judge there is nothing conduces so much to the advancement of philosophy as the examining of hypotheses by experiments and the inquiry into experiments by hypotheses, and I have the authority of the incomparable Verlum to warrant me. So basically he's saying, no, I don't buy it. Newton's not making any sense here. Okay, so let's move on to Huygens. This is a very young portrait of Christian Huygens. In fact, it looks like Oldenburg had to work quite hard to get Huygens to sort of take a position on this. Oldenburg kind of kept on sending him letters going, no, but what do you think about that paper? And Huygens is like, it seems fine, it seems interesting, whatever. And Huygens really had to kind of work quite hard for finally Huygens to go, okay, fine. I don't agree with all of it. Here are some of the things I don't like. Okay, so again, I'm just going to focus in on two objections that were raised. Firstly, that we shouldn't postulate more than two colours. Huygens offered a methodological reason for this, that it will be easier to explain two colours than indefinitely many colours. And also an empirical reason that he thought that white light can be produced by mixing just two colours, so we don't need all the colours. And so something like this is what he thinks you can do. Although Huygens did admit that actually he hadn't tried this experiment yet. But he thought that in principle you should be able to. Okay, so Newton quickly makes quick work of the methodological reason. Newton just points out that, look, fewer colours doesn't necessarily mean fewer or simpler explanations of things. And so he points out that where his model, Newton's model, requires just one explanation, just the number of, that there are indefinitely many colours, Huygens' model requires two. You have to have the you have to explain why there are colours, and then you have to explain why there are only two, and why those two are the ones. So it just seemed way more complicated. But anyway, that's not really the interesting response here. So, okay. So again, Newton pulls his trick of raising queries, trying to raise this as an empirical disagreement. So he says, since Huygens seems to allow that white is a composition of two colours, at least, if not more, give me leave to rejoin these queries. Whether the whiteness of the sun's light be compounded of the light colours, whether the colours that emerge by refracting that light be those component colours separated by the different refrangibility of the rays in which they inhere. So he's raising queries again, and here's kind of how he responds to these queries. Firstly, he challenges the accuracy of the experiment. He says, well, look, I seriously doubt that Huygens has actually managed to do this, and if he did, and this is where Newton calls on his distinction between original and compound colours, he says, well, look, if Huygens did manage to do this, this yellow and blue are probably compounds. And we'll find out that by putting that white mixture through another prism, and what he predicts we'll find is that we'll get the whole spectrum coming out the other side. And so he makes this recommendation to Huygens. He's like, look, if you're going to try this experiment, make sure you've got original yellow and original blue and no other colours before you try and make white out of them. Basically, you could do this by kind of running an experimentum crucius and putting some extra lenses in there to direct the colours to the same point. But then he also goes on and makes a second point. He says, look, this isn't going to refute his theory anyway if this turns out to be the case. So he says, look, if white were produced out of original blue and original yellow, it would only separate into blue and yellow. That's how the experiment would look. And so this isn't a problem for him for two reasons. Firstly, it would have different properties to sunlight. What we'd find is that you could have white that has different kinds of properties. And it would still show that white has to be composed of other colours, that it's a mixture of colours. And so it's still going to be heterogeneous. And so for Newton, this wasn't a problem, although Newton continued to be, well, after that point, was very clear to always talk about sunlight instead of white light after that. Okay, and so the second objection that Huygens raises is this one, that the explanation is incomplete. That without a mechanical explanation of the nature of light and colours, Newton has not taught us about the nature and difference of colours, but only the accident of their different refrangibility. Newton's response to this is to draw a distinction between hypotheses and theories. Again, he goes methodological at this point. As far as Newton is concerned, a hypothesis is something that's at best only highly probable, whereas a theory is something that's certainly true. A hypothesis is a conjecture or speculation, so it's something that's not deduced from experimental evidence, whereas a theory is experimental, so it's inferred from observation and experiment. And a hypothesis is something concerning the nature of the phenomenon rather than its physical properties, whereas a theory concerns the observable, measurable properties of the thing rather than its nature. Okay, so this is the distinction that Newton is drawing here. And so, for example, as far as Newton is concerned, that white light is a heterogeneous mixture of rays is a theory. It's something that's certainly true, it's experimental, and it conserves the observable, measurable properties of things, whereas something like that light is a substance is going to be a hypothesis. So it's at best only highly probable, it's speculative, and it concerns the nature of the phenomenon. So it's not that Newton didn't like kind of speculating about things like the nature of light. He certainly did a lot of this. He just didn't think it was appropriate to do that in a scientific paper where you're putting forward your theory of light and colour. A hypothesis is all well and good. It can act as a possibility proof, or it might sort of suggest further experiments and all. But you need to kind of clear it out. If you're going to argue that for a theory, you shouldn't kind of muddy the water by kind of including hypotheses in there as well. Oh, and by the way, this is what Newton means in the Principia with his infamous phrase, hypothesis non fingo. Okay, so that was his claim. And so Newton responds by saying this: to examine how colours may be thus explained hypothetically is besides my purpose. I never intended to show wherein consists the nature and difference of colours, but only to show that de facto they are original and immutable qualities of the rays which exhibit them. And so the point here is that Huygens's demand was clashing directly with Newton's methodological commitment to providing theories rather than hypotheses. And again, was Huygens convinced? Well, probably not. In a letter that he wrote later to Oldenburg, he says this, as to Mr. Newton's solutions to those objections which I made to his theory of colours, they might be answered and new ones started, but perceiving that he maintains his doctrine with some concern, I shall dispute no further. Basically, he's going, no, this is a crazy guy who's just way too committed to his theory. And that was actually a bit unseemly at this point. You're supposed to be a bit more epistemically modest than Newton was being. Okay, so those are so I'll wrap up now, quickly. Okay, so some reflections on these disagreements. This is a point which I didn't really have much to say until yesterday, I think. So one of the issues that was kind of raised yesterday is about how in real disagreements there needs to be some sort of shared standard. And I was sort of trying to figure out what kind of shared standard there is in this debate. So one thing is that they all have the experimentum crucius in common. They've all managed to successfully carry that out. But the problem is that they all read it differently. And so even though they've all kind of produced the same phenomenon, they're seeing it differently. You know, Hooke thinks it supports his view that white light is primary and that the colours result from you know messing up the rays, whereas Newton thinks that what it shows is that those properties are already in the white light to begin with, and so on. So I'm just not sure if this kind of counts as a shared standard. And in fact, kind of what's going on at this point is that they're really, that Newton's kind of trying to change the standards on them, right? I mean, other shared standards could be that they all think that you need to have kind of a mechanism, a mechanical hypothesis that underwrites your theory. But again, Newton's saying, no, that's not the way we should do it. So I'm not sure. I feel like Newton's kind of changing the rules on them. And there is a sense, the first few times I read that correspondence between them, I kind of thought, well, they're sort of talking past each other. But I think something more than that is going on. But I think they don't quite know what to do with Newton changing the rules on them. Another thing that kind of came up yesterday that I think is kind of important here is there's this kind of question of who the experts are. In this case, you know, Hooke and so there are a bunch of these people. So we've got Newton, who kind of eventually becomes an expert. We've got Robert Hooke, who's already a heavyweight in this field. His Micrographia had been published a few years earlier. Newton had read it. Hooke was fancy. Huygens, his theory of light came out a couple of years after this, but everyone had already read it and knew that he was one of the shit hot dudes. I've never been able to find a picture of Reverend Parties, so I tend to use this one of him. He was a Jesuit natural philosopher who also was another optical heavyweight. He kind of weighed into this debate. And in fact, his theory, his book on light was never actually published, but from what we can tell from the correspondence that's going around at the time, all these guys had read the manuscript of it. So he was another heavyweight. And again, the problem is that Newton's kind of coming into the middle of this and being extremely disrespectful of his superiors, right? And so again, there are kind of problems with this disagreement because they don't know what to do with this, you know, young upstart, this guy from Cambridge who's never hung out with them or anything. Okay. But I think that maybe what's interesting about this debate is that this kind of could be seen as a seminal moment for scientific disagreement in a certain kind of way. I think that what's going on here is something that was fairly new at that time, and they're sort of trying to invent the rules as they go. I mean, you get this sense from reading Newton's first optical paper that there really aren't that many scientific papers before that. He's kind of making up, as he goes, kind of how it is that you're supposed to write one of these. And I think the same thing kind of goes with this scientific disagreement. Newton seems genuinely puzzled when the other people in this debate kind of don't immediately look at the experimentum crucius the same way he does and immediately kind of go, oh, of course you're right. He seems genuinely puzzled by this. Yeah, and so those are just some thoughts, and there are some references, so thanks.
Okay, so we have about 9 minutes for questions. Well, yeah.
Okay, so I wonder how far you want to push that last claim, right? So you might say something like, so lots of us
It's a
think
question,
about...
not a claim, but yes. Did I say it not with inflection? Anyway, yeah.
So you know, we tend to think about, when most people have been thinking about disagreements as being kind of abstracted from history in a certain type of way. The idea is there's this thing called disagreement, and it doesn't, you know, there are these properties that we can pick out that really matter. I mean, there's a kind of historicity going on in that query, right? Like, do you think that there are sort of properties that were in that debate which kind of have led to scientific disagreements being a certain way when they could have been otherwise?
But I haven't thought very much about scientific disagreement beyond this kind of case. But I think some of the features are things that kind of came up yesterday, and this morning too. Things like, Newton's use of those queries to try and kind of clarify the points of empirical disagreement between these views, and sort of he uses queries to try and speculate on what kinds of observations we might make or experiments we might carry out that could choose between these different views and so on. So I think that's something that that is kind of important. I don't know how often people are doing this kind of thing before that. My understanding is that Newton is using queries in a very new way compared to his contemporaries, and so I think this could be something that's quite important, this kind of trying to, empirical contention, I guess is what you called it, which was disputed around the place. But I think this could be important in terms of a way in which disagreement became a thing that people did.
Thank you. That was really fascinating. And I guess kind of following up, I had a few questions, but I guess the two main ones were, I was wondering whether in reading your primary sources you have come across any attempt at spelling out the difference in terms of different mechanical explanations, because presumably, as far as I know, there were both kind of corpuscularians, you mentioned this, but they had different views about what those corpuscles were like, and I know that Newton was quite, in the queries of the object, sometimes he mentioned Hooke's in very disparaging terms because he believed in springy atoms or different kinds of atoms from, so I wonder whether there was some mechanical explanation that could act as the base of the disagreement. The other question I had was, to what extent Newton, in a way, had the upper hand in the debate, because his view was also able to explain other phenomena like the Grimaldi rings that I think were known before him, and to what extent that evidence could count as evidence for Newton but not for Hooke.
Right.
And I don't know
Yeah.
whether that's correct or not, but I was thinking.
So I'll answer the second question first, which is that I think this is another way in which Newton seems genuinely puzzled about why they haven't all accepted the theory. Because, Hooke gives us a 5,000-word paper where he doesn't explain all the experiments. He just focuses on that one claim. He's like, okay, so there's a new phenomenon, a new property of light, and here's very briefly my theory of color. And even says in that paper, look, there are other experiments, but look, I don't want to bore you with all the other experiments, so here are just two. But we know from the manuscript material that he'd already carried out the experiments on the rings, and he'd read Grimaldi, and he was still, the problem with the coloured fringes was that he was never able to kind of actually properly deal with that. But he'd already figured out the coloured rings and how he was going to explain those and so on at this point. It's just, this is all kind of hidden from everyone, and he kind of thinks, no, but I figured all that stuff out. Like, why can't you just see how brilliant this is? And so there's a sense that while Newton perhaps should have had the upper hand, he doesn't reveal it all at once. This is also because Newton's so intellectually jealous that he's probably withholding it till he could actually put it out there, and so even though maybe he should have had the upper hand had he actually put out the whole lot, I think that my view is that Hooke and Huygens and parties, as the optical heavyweights, probably did in fact have the upper hand, kind of socially at least, and that Newton probably would have done better maybe to defer to them in certain ways or been a bit more respectful. Maybe they would have been a bit more open. As for the issue about kind of the mechanical hypotheses that are underlying the theories, I tend to look at Hooke as more of a wave theorist. And the reason why I think this is because while Newton and Hooke both have this kind of optical ether, for Hooke the light is a wave, is a kind of a disturbance through that optical ether, whereas for Newton the light is actually something separate to the optical ether. It's some sort of substance which is causing vibrations through the optical ether. And so they've actually got different views on that. What's interesting though is that Newton kind of writes this up in a later paper about 3 years after that and sends it to the Royal Society, and upon reading this, Hooke announces to everyone there that basically Newton's stolen his theory. Or hypothesis, and that's just not true. Like, when I look at the two, they're very different in that respect. Did that answer that question?
Yeah.
Yeah, okay.
Thank you for an outstanding talk. I really enjoyed that. Can I ask, I've never been clear on this, but I think you made such a clear disposition. Could it be said that it seems to me Hooke's objection to Newton's paper is ironically very, very like my reading of Thomas Hobbes's objection to Boyle's air pump? Because where Newton thinks or maintains that he's using the prism as a sort of a microscope to examine nature, Hooke maintains, no, you're creating an artificial reality. You're not breaking nature down into parts. You're creating something new. Is that it seems to me that's the nature of his objection, isn't it?
I hadn't really thought about it like that, but I think that could be a way of looking at it. Yeah, where it certainly seems like Hooke thinks that Newton has kind of artificially created the colours and that they're behaving in a certain way, but that's not actually telling you what's in the white light. And that's interesting because Hooke doesn't dispute that this is the once you get the colour, that the refrangibility is going to be what it is. The disposition to refract is going to hold constant too. He just doesn't think that tells you about white light.
If I may, that was the other part of my question. So would you say at the time, was Hooke's objection justified at the time in terms of the actual experiment?
Yeah, I mean, like I showed you how, I've sort of had to think long and hard on this because, when I first started looking at this, I was like, look, Hooke's is obviously wrong, or maybe, and then I kind of flip-flopped and said, oh, no, Newton's obviously wrong, and, but then I just realized that, no, and then I sort of took careful reading of the text to go, oh, wait, Newton's not even talking about color at this point. And I think that they really are. I think this is a case where there's genuinely interpreting the experiment differently. And you only, it's also that because Hooke because Hooke's a wave theorist, he just doesn't think of different that there being kind of these different rays of light that have different properties. Like that's just, like this is kind of incomprehensible if you're a wave theorist in a way. And, even now they kind of struggle to explain some of this stuff or like to kind of describe it in ways that people can kind of get. And yeah.
Okay, thank you very much.
Thanks. Oops. Yeah.
Parameterization. I guess it's a long word, isn't it?
Just given the document.
Yeah. What do I need to? Is that it? Should that? Good, we've got to go.
You better get started. Okay, so I'm delighted to introduce Hooke Akagi from the Texas Christian University and associated with When Experts Disagree, giving his paper entitled You Say Potato, I Say Parameterization, Modeling Conceptual Disagreement by Tracking Background.
Right. Thank you very much. Right, I'm going to give you a quick outline of what I'm going to do. I'm going to try and move quickly and efficiently because I have more ground to cover than I thought, so I may wind up skipping a few things as I go that aren't totally essential. So I'm going to begin by outlining a phenomenon of interest, the thing that interests me, this thing that I call conceptual disagreement, and I'll give you a couple examples, skip some other examples, so if you're hungry for examples, you can ask for more. And then I'm going to talk about a few different ways of modeling the phenomenon. The sort of vagueness approach and what I'm going to call sectarian approaches are kind of classical, and parameterization is this other kind of quirky thing that I'm going to then explain. I'll sort of show you how it works, work it through with an example again, and then at the end, depending on how much time I have, I'll talk about some of the advantages of the approach as I see it, and some of the worries that you might have about it, anticipating some of your concerns. So the talk is in general very methodological talk, but I hope everyone can follow along with me here. So let's talk about conceptual disagreement. Before we talk about the disagreement part, we should talk about the concepts part and what I mean by concepts. So concepts, in the sense that I mean to use the word here, is concepts are like theoretical terms, a term that philosophers like to use. Essentially, they're things that are like words, but indifferent to a particular language. So the English word marriage, or the French mariage, or the Japanese kekkon are all distinct words, but they correspond to a common concept. Or if you have worries about intercultural comparisons or something like that, the fact that I'm mostly focusing on scientific examples should, I think, make those worries seem less pressing. Scientists are all trying to speak the same theoretical language, even if they use different words to talk about the same theoretical concepts. So that's what I mean by a concept. Nothing a whole lot more tricky or mentalistic than that. Something that I think is fairly uncontroversial about concepts is that there are rules for using them properly. If I tell you that this table is deep and briny, then that doesn't seem to make a lot of sense. I must have used some concept the wrong way at some point. There are rules for the correct use of concepts, just as there are rules for the correct use of words. And these rules can be explicated or made explicit. Doing this is, what looks normally like what we call conceptual analysis in philosophy, although for various reasons I tend to stay away from the term analysis. It brings up strange associations in some people's minds. I don't think that explicating a concept is necessarily articulating like the deep meaning or the true nature of the concept or anything like that. It's just a description of some of the rules that we as a linguistic community observe when we use these concepts, right? So that's background about concepts. Now I'm going to talk about a few varieties of disagreement. Suppose I tell you, hey, Chuck and Eugene are married, right? There are a few different ways you could try to disagree with me here. So you might say, no, you're jumping the gun. The ceremony's not until next month, man. That's a kind of factual disagreement. The evidence that I've given you about this particular exchange doesn't suggest that we're using different rules for any of our concepts here. The disagreement is not about the concept, it's about something else. Call those other things facts, if you will. Or there's what's commonly called verbal disagreement or merely verbal disagreement. So maybe I say Chuck and Eugene are married, and you say, well, legally it's like a civil union. And I can say, like, come on, like, what we want is to get like the department together, and we're bringing the spouses in too, and like obviously Chuck and Eugene are married in the sense relevant for that, right? It's not like we're going to exclude them. And you might say, yeah, sure. So the kind of exchange I have in mind here is where once we clarify the way we're using the terms, everybody's sort of on board, right? Like, in a legal context, marriages and civil unions might be a sort of different thing, and that might be relevant and important, but like in the sort of social context that we're actually talking about, it's not a distinction that matters at all. So this is what might be called a merely verbal disagreement. Once the distinctions are sort of observed, everybody's like, all right, we're all on the same page, or they should be if they're being good faith interlocutors. I want to talk about a third kind of disagreement, which some people call conceptual disagreement. So I won't put you in the position of the other interlocutor here. So maybe I say Chuck and Eugene are married, and my uncle says, no, they're not. Marriage can only be between a man and a woman. And Chuck and Eugene, they sound like two men, don't they? So the kind of disagreement here is different from these, right? The disagreement is not about what kinds of ceremonies have taken place or anything like that, nor is it the sort of thing that gets sorted out once we get clear on the different ways that you might use the word marriage. The disagreement here is about what the rules should be for using this concept, right? What is worth meaning with this concept? Elocution that people use sometimes is what conception of the concept is the right conception or a permissible conception. Right. Hopefully this illustrates a little bit of what I mean by a conceptual disagreement. It's the kind of thing that Burgess and Plunkett, for example, talk about when they talk about conceptual ethics, right? Conceptual ethics as a nascent field is about resolving conceptual disagreements. So this is important not just for like sort of socially interesting concepts, but it also is important in science, and that's because intellectual progress, including progress in science, involves a number of things. Of course, it involves learning new facts about the world. The Earth revolves around the sun, not the other way around. Like, that's good. It's good for science. But scientific progress also involves refining our concepts, and this can take a number of different forms, right? So we can develop new concepts like oxidation in chemistry after Lavoisier, or germ in the germ theory of disease, or eggcorns in sociolinguistics. If you don't know what eggcorns are, you should find out. It's gas. Sometimes refining our concepts involves discarding old concepts that we don't like so much anymore, that don't really help us out so much. So concepts like the ether or animal spirits don't appear in our contemporary science, although they can appear in some older science. And refining our concepts can involve revising old concepts, changing the acceptable rules for using the concepts. So we used to think of atoms as necessarily indivisible constituents of matter, and now, of course, they're famously divisible in some sense. The ordinary language concept of memory is, in the hands of psychologists and cognitive scientists, become much more complicated in order to accommodate the kinds of phenomena that they're interested in. So now we distinguish between things like short-term memory and long-term memory, episodic memory, semantic memory, and so on. So the concept is acquiring distinctions, complications, and getting worked into a shape that's more helpful for the science. And I've spent a lot of the last few years thinking a lot about revisions in the concept of cognition. I'm not going to talk about that a whole lot today, but I've talked about it on other occasions. So let's talk about some examples of these complicated concepts from science and beyond, sure. So Samantha and Leif Hancock-Lee have a lovely little manuscript wandering around now about the concept of woman. Relatively ordinary concept, not necessarily a scientific concept in the sense that I mean it here, right. People disagree about the extension of women, like which things in the universe are properly described with the predicate woman, right? Some of the things that make this more salient these days are admissions policies at women's colleges, who should be accepted or as a candidate for acceptance at a college like Bryn Mawr College or Smith College, and who gets to participate in women's sports leagues, like women's MMA fighting, who gets to participate in that. So according to Samantha and Leif, whether you're called a woman can depend on a number of different factors depending on who you're asking. This box here represents our universe of discourse, right? And I'm going to fill it in with some circles representing extensions, right? Things that are referred to by the predicate woman in sort of like Venn diagram conventions. Whether someone is called a woman can depend on things like whether they sincerely identify as a woman, whether they're oppressed in the manner characteristic of women in patriarchal societies, whether they have a feminine gender presentation, whether they occupy feminine social roles, whether they have female reproductive organs, and things like that, right? And one thing you'll notice, so plausibly, when you map these things out, there's going to be a sort of core a set of core cases where all or most of these circles overlap, right? The paradigmatic cases of women, cases where more or less everybody agrees, like, sure, this person belongs in the extension of woman. And then there's going to be a penumbra of controversial cases. Now, I'm not saying anything about these controversies here, whether they're good or bad or anything like that. I'm just saying that they are controversial in our linguistic community, right? If we move on to, so this is going to be my main example for this talk, a scientific concept, that of selection in the sense of natural selection, right? So Stellan Olson and others write about this Darwinian explanatory framework that explains things like the evolution of species through natural selection, but also a number of other things. We can ask what kinds of processes are subject to this process of selection that Darwin describes. We've got a big discourse universe here. So the obvious case, of course, is the evolution of species. We've got our peppered moth here as our avatar for this. But there are also a number of other processes that look similar at an abstract level. So cases of breeding, for example, Darwin describes as artificial selection, distinct from natural selection in various ways. This is a domesticated fox, an Instagram star. But if you have a conception of selection that includes not just natural selection, but also artificial selection, you've got a slightly different extension, right? It's also been suggested that like internet memes might sort of live or die by similar kinds of processes, right? Whether something sort of like fails and like falls to the bottom of 4chan or becomes like very visible around Facebook and spreads around, right? Maybe there's a similar sort of process there. And of course, Richard Dawkins suggested that maybe cultural development in general, or in many cases, follows a similar kind of structure. And even weirder things like evolutionary algorithms, right? These are algorithms designed by computer scientists using methods that are inspired by Darwin's process of natural selection. So we've got a bunch of strange things, and you notice these don't have this core and penumbra structure, right? The things that belong in these extensions are all different kinds of things. And if we want to go back and focus on the evolution case, even within contemporary theoretical biology, there is an awful lot of controversy about what exactly are the processes that are being referred to when we talk about natural selection. And this often, so for example, this happens in the case of debates about the so-called units of selection. So you might think that the things that are getting selected are just genes, if you're a selfish gene theorist like Richard Dawkins, or maybe they're whole organisms, or maybe they're groups of organisms, although suggesting that it's a group of organisms is one of those reputation traps of the kind that we discussed yesterday. But there's disagreement here. So maybe there's a kind of core and penumbra structure here, but there's a lot of other things out in the world that might belong in the extension of a concept like selection. We'll come back to this example. So what do we do when we want to understand cases of disagreement or the structure of these complicated concepts? Well, there are a few, first, let me say, just for the sake of being very explicit, this is the form of a traditional conceptual explication, right? You've got universal quantification over some universe of objects, and on the left-hand side, you've got the explicandum concept, or the thing that you're explicating, like selection or woman or bachelor or whatever. You've got some kind of connective in the middle, and on the right-hand side, you have the explicating expression, or the explicands. These are ideally, they're a set of individually necessary and jointly sufficient conditions. Maybe you just have necessary conditions or just sufficient conditions. You've got some weirder kind of thing that you want to say. You just change around the connective. You can do all of these things. But this is the general form of an explication. Just to make that clear. So I'm going to talk about a few different ways of modifying this traditional schema to accommodate these complicated concepts with these sort of overlapping extensions. So the easiest case might be vagueness, in the sense of like fuzzy vagueness or gradable vagueness. So what you do is you put some like property that can be graded somehow in the right-hand side of the expression, and you can produce a theoretical object and explication that's got this fuzzy extension, right? So an example might be obese. I could talk about this a little bit more, but in the scientific literature, like the concept of obesity doesn't have, or of an obese person rather, doesn't have a sharp boundary, right? Different experiments use different standards, usually some kind of ratio like a body mass index or something, and you just set an arbitrary cutoff. The cutoff differs from paper to paper. Some papers don't use body mass index, they use a different measure or something, but that's fine. It's as long as you're careful in your literature reviews. The fuzziness doesn't create a problem. These kinds of concepts are appropriate for some kinds of circumstances where, the precision in our ability to measure far outstrips like the value in being really precise. So that's fine, but it doesn't produce the right kinds of extension, especially for a concept like selection, where it doesn't necessarily have this core and penumbra structure. you can't just like throw a graded notion into the right-hand side and get something that's as weird looking in terms of the variety of objects it refers to as natural selection, right? So this strategy isn't super great for understanding those cases. Another common thing that philosophers do is take what you might call a sectarian approach. You just have different explications for different, you make a distinction, you have different explications for different versions of the concept, right? So a familiar example might be theory. There's, of course, an ordinary sense of theory or ordinary language sense of theory, where theory is something like a baseless or random speculation or about something. And then there's the scientific sense of theory, where a theory is an explanatory device that should explain a large number of phenomena. Ideally, it's well confirmed by a variety of different kinds of evidence and so on. So what is the important conceptual link between a theory in one sense and a theory in the other? Like, well, I don't know, it doesn't really matter. There's not a whole lot that hangs on seeing these things, ordinary language theories and scientific theories, as like of a piece or similar in some way. So that's fine. You can take a sectarian approach, just have different explications for the different concepts there. But in a lot of contexts, scientific contexts where people are disagreeing about the right way to use a term, there's something more going on there. We might want to be able to capture what parties to the disagreement are agreeing about, and what they're disagreeing about, and why it matters, right? If you take this strategy, there's no clear, obvious, or important connection that's suggested between the different uses of a concept. So if we can do better than this, I think that would be great for some kinds of contexts. And so what I'm going to talk about is parameterization. So it's easy. In parameterization, the right-hand side contains parameters that admit of multiple values, which you can also call interpretations, where different combinations of values yield different extensions. Great. I'm going to go through an example so that that sentence makes a little bit more sense. So, right, I had prepared a slide where I defended my use of the word parameter here. We can skip this because it's not super important, which you can ask about it later if you want to. Here's a toy example, right? Here's a toy explication. An action phi is brave if and only if phi is dangerous for its agent and phi is admirable. And I've highlighted admirable in red because I'm going to be treating this predicate as a parameter. So imagine this case. This isn't actually a picture of Marilyn, but imagine Marilyn. Marilyn likes skydiving. Now, let's assume that skydiving is dangerous for Marilyn. And the question is it brave of Marilyn, or is skydiving brave when Marilyn does it? Now, Marilyn's son might say, no, it's not brave. It's dangerous, but you're just having fun. And like, think of all the people who would be hurt and upset if something happened to you. It's selfish of you to do this. I think our intuition, for the most part, is that Casson would not be inclined to call Marilyn brave for doing this if he doesn't see it as an admirable quality, right? On the other hand, Marilyn's friend Chandana might say, like, well, you know what? Like, I think it's great that you skydive. You're a woman of a certain age, and you're just like doing what makes you happy, and you're not worrying about other people. That's brave. That's a political act. It's you know, you're really showing the world something about like what women could be, and like I think it's fantastic. I think it's a marvelously brave thing for you to do. Right? It's just a toy example, but part of what you want to say about like brave on this explication is that we can't really evaluate whether an action is brave or not without without giving some interpretation to this extra parameter admirable, right? Unless we have a context of assessment or something that tells us whether which actions are admirable and which actions are not admirable, we can't apply the concept brave. But once we have that, we can sort of predict what's supposed to be in the extension of brave. And what this explication does, among other things, is establish the relationship, right, between variability in judgments about admirableness and variability in judgments about bravery. A more controversial and emotional example might be kamikaze bombers, for example. And in general, with suicide bombers, you find this interesting pattern where if you don't approve of the suicide bombing and the causes for which it's being done, people have more of a tendency to say of the action that it's cowardly than that it's brave, which, I don't know, seems like an interesting linguistic observation. But again, you have a way of explicating this concept, the concept of bravery, and predicting its extension based on its relationship with some other concept which serves as a parameter in the explication. So in more traditional kind of explication, you might want to come up with clear criteria for what it is to be admirable, but you don't have to do that in a parameterization. You just have to explain the relationship between the parameter and the explicandum concept. So let's talk about scientific concept, selection. This is again kind of a toy example, but here's a toy explication of selection based on Richard Lewontin's remarks in 1970. We can say that selection occurs where there is a population of individuals, where individual is going to be treated as a parameter here. There's variation in the traits that those individuals possess. The possession of the traits is partly heritable, in some sense of heritable, and variation in traits causes variation in individual fitness, where the interpretation of fitness is also going to be up for grabs to some extent. So this is our toy explication of selection. Now let's imagine a few different combinations of interpretations for these parameters. So we've got our parameters here on the left-hand side, individual, heritable, and fitness. Now if an individual is something like a Darwinian individual in Godfrey Smith's sense, and heritability means something like germline transmission, and fitness is the number of offspring occurring in natural conditions or something like that, right? Like I said, theoretical biologists argue about how to interpret these things correctly. This is just a toy example, but if you set the example, or if you set the interpretations of the parameters so that it's something like this, you get an extension for that explication that looks a lot like the predicted extension of natural selection, right? Now, if you take the same interpretations and change the fitness parameter to include to mean not just the number of offspring in natural conditions, but the number of fertile offspring selected by a breeder or something like that, then you get an extension that looks like the predicted extension of artificial selection. And you can keep fiddling with this if you mess with the parameters a bit more, where an individual is something like a cultural artifact or a meme. Heritability implies reproduction by humans or in human minds or discourse or something like that. And fitness is the number of offspring in the culture. However you interpret that, you get something that looks like cultural evolution. And likewise, with evolutionary algorithms, it's a way of setting the parameters so that we get sort of predicted extension out on the other end of this. So again, this is a toy example. Maybe some of these settings for parameters turn out to be incoherent. There are a lot of people who don't like the idea of cultural evolution. They think it's a bad metaphor. Maybe it's going to turn out in closer examination that this doesn't work out. Don't have to say anything about that. What I want to say here is that this theoretical object here, this toy explication, does something interesting in that it is a perspicuous representation both of what is in common across these cases, with explicit places for marking the most likely loci of disagreement between people who like or don't like certain ways of extending the concept of selection, right? And again, right, what we're getting is exactly this kind of strange-looking, partially overlapping structure for the extension. So why do this? So first of all, you might just be interested in being able to do this for some reason, and this lets you do it. It's not particularly moving if this kind of conceptual complexity isn't interesting to you, but it's interesting to some people. And it's got virtues. How much time do I have left, by the way?
About 15 minutes.
15 minutes. Oh, I'm...
With questions.
With questions. Oh, right. All right, well, I'll just keep moving along at this pace, and hopefully things will work out. Right. This has got advantages over the vagueness and the sectarian strategies, right? It gets you this sort of pluralist shape without appeal to something like Sortes vagueness or graded vagueness. And unlike the sectarian approach, it gives you explicit resources for describing what the relations between the different conceptions, right? It shows you both what is in common and what is different in different ways of understanding the concept selection. There are various dialogical virtues. It makes explicit matters of agreement versus disagreement, and in cases where you might be afraid that parties to a disagreement are going to wind up talking past each other, the existence or availability of a unified explication like this can promote something like conceptual empathy, some kind of handle that parties to a dispute can hold on to understand each other and give them dialogical virtues that might protect them from straw manning each other or something like that. And I'm going to try and move quickly here. There are also various other kinds of discursive virtues that this approach gives us. The parameters, so which terms you choose to treat as parameters, correspond to what Robert Brandom calls paths of Quinean retreat, that is like progressively less contentious resources for appeal, the kind of thing that I think Adam was talking about yesterday when he was talking about metanorms. These metanorms don't have to be Archimedean, but you've got, if you're arguing about which norms are the appropriate norms for using a theoretical concept, the places where you're most likely to find continued disagreement as you try to appeal to progressively less controversial theoretical resources, those are going to be the parameters, right? So those are highlighted for you. Parameters might also correspond to topics that are ripe for further philosophical work. So the selection case is kind of easy because the theoretical biologists have been over and over these cases. Everybody knows that units of selection, fitness, and heritability are really controversial notions for concepts that are less well discussed in literature. You might discover really interesting parameters that you didn't expect, and I would argue that that's the case in the concept of cognition. And if there are multiple parameters, it might be possible to work on some of those topics in isolation from each other, or it's not possible. There might be constraints on the combinations of permissible interpretations, and if there are such constraints, it's further an interesting research question to wonder why there are the constraints they are. Anyway, there are various features of this approach that raises further research questions that could potentially be fruitful and interesting in understanding the conceptual structure of our scientific theories. And I've just got 10 minutes left. Yeah. All right. Well, I'll highlight the worries and objections real quick without really describing them, and if it looks like something that you're interested in asking about, maybe you will. So you might worry that this seems like a really complex approach, and I would just say that complexity can be counterbalanced by other things. I'm not going to talk about those right now. You might say that this doesn't solve all of our problems, and it's right, it doesn't solve all of our problems, but it is a format for helping us get a grip on some of them. Right, and again, this isn't a solution to a problem, it's a form for a solution to a particular kind of philosophical problem. You might worry that it's vacuous. I would say no, it's not, for reasons. You might worry that there's a regress. I would say yes, but it's not an infinite one, again, for reasons. And just to wrap up real quickly here, I described this thing that I call, and some other people call, conceptual disagreement. I talked about a few different ways of modeling it and promoted my favorite, right? Which won't solve all of these problems for all of these contested concepts, but will help us with some restricted class of them. And I talked a little bit about the advantages. I didn't really tell you about the worries, but I'm sure you have some of your own. That's all I have to say. Thank you very much.
Okay.
All right.
You had 10 minutes and you took like 2, so we've got plenty of time for questions.
Excellent.
Yes.
I really appreciated how clear that was, and I take it that in a sense when I'm describing what you're doing is there's this kind of multi-dimensional approach that people like PGS and Sutherland have been using for a while.
Exactly.
And you're kind of describing it in an abstract way, which I think is really useful. What I was confused about was I sort of felt like what you wanted when you're with your Venn diagrams, the Venn diagram you're focused on, where it was kind of disjunctive,
Mhm.
which you kind of wanted a sectarian answer, not a parameterized answer. So let me try and explain. So my immediate thought when you gave the selection case was, well, that's not, the Venn diagram is not describing selection, the selection case, where they're disjunctive, where they're not touching.
Mhm.
Because obviously they are unified by something like PGS's story, which then went on and argued, right? So maybe they don't understand what the Venn diagrams are showing. But all of those were populations that met the criteria given the recipe view. And so they're overlapping. There's no gaps. You know, like it might be that they're not overlapping perfectly, right? But there's not going to be gaps between them. And so it sort of struck me that if you want this sort of gaps case, then selection is not a good case. Whereas perhaps certain views on the nature of like proper pluralism about species or proper pluralism about genes or something might be look more like those kind of the Venn diagram where you've actually got a disjunction. And the worry was something like, well, if you've got the disjunction, then surely the right thing to go is sectarian, right? Like if in fact there's no overlap between these two things, then why would I create some weird space where there's kind of these completely unoccupied bits of it?
Yeah, I'm not sure I quite understand your remark about the overlaps.
So on the Venn
yeah.
diagram, the one you're interested in,
Yes.
you had two circles that didn't overlap at all.
Yeah.
There was no point of contact.
Right.
So on the view you gave of species, of course there was overlap on the Venn diagram, because all of those things are populations that meet those criteria to some extent.
Mm-hmm.
And so that's not representing the Venn diagram you were going for, right?
Well, maybe I can call back that diagram real quick so we can talk about it. So this diagram.
Yeah.
So the thought here, so the timing went a little bit quick, but the thought here is that all of these sort of theoretical biology cases are in a cluster here because they kind of cover the same kinds of, well, depending on your metaphysics, right, they cover the same kinds of objects, and I don't know, maybe genes and organisms and groups aren't really coextensive because they're whatever, but they're similar kinds of conceptions, whereas particularly stuff like cultural evolution and evolutionary algorithms seem like they've got really different objects.
But didn't you argue that they don't? That the objects are different, sure,
Mhm.
but for the relevant thing, they're overlapping because they're all evolving populations.
Yeah, well, I mean, like, there's a question here about like what the order parameter is in this space and like why some things are separate rather. I mean, like, yeah, I mean, I could put a space and just put up one diagram, one circle here, and say these are the processes that are subject to selection, and that would be another way of carving up the discourse universe. Yeah, but the intuition that I meant to sort of pump with this picture was one that acknowledges that among people who think about things like selection for a living, right, there is a lot of disagreement and contentiousness about whether these processes belong in the same category. In particular, some of them seem like they concern such different objects, and there are such different, local constraints when you really get down to the nitty-gritty that it's not worth calling the same kind of thing. So, yeah, I mean, like playing with Venn diagrams is always kind of tricky.
It's a picture of extensions, not intentions.
Right. Yeah. Well, yeah, I mean, yeah, I suppose. Although, in a way, right, it might have been more correct to take all of these clustered pictures and explode them in different ways depending on your mereology or whatever, right? But yeah.
Let's move on. We've
Yeah.
got a few questions.
One very quick thing is about one of the first examples you gave about
Yeah.
being brave, and the example of the old woman and the woman.
Mhm.
That's skydiving. There, I wasn't really sure that it was an illustration of any conceptual disagreement. It seemed more that the people who were debating would agree on the concept brave, and then just not agree on whether what that woman did was an example, an instance
Right.
of that concept. So that wasn't an example which really convinced me. And talking about more what better examples for your own proposal, I was wondering whether the idea is that the parameters stay fixed, and then, let's say there are 3 parameters,
Mhm.
and then depending on the cases, some of them, the relevant cases may instantiate different combinations of these parameters, but maybe not all of them. Or whether the issue was that these parameters could be differently interpreted, so that on a different interpretation of those parameters, then all of these possible instances would satisfy all of them.
I see. So I'm not sure if I'm going to answer your questions, but let me give it a shot, and you can let me know if it's really unsatisfying. So on the bravery example, the main point of that was just to be sort of intuitive example of how a different interpretation can produce a different extension to illustrate how parameterization works. So if it's not a great example of conceptual disagreement, I don't mind a whole lot. I think the other examples like selection are better examples. I would agree with you that they're better examples, and bravery is a toy example. So I can concede that. And about the way the parameters are supposed to work. So in a more clear mode of speaking, I might distinguish between different kinds of extensions. What I've sometimes called sectarian extensions, where when you fix a particular set of interpretations for the parameters, you don't get all of this stuff, right? You just get like one of these circles, right? And if you set the set of interpretations for the parameters differently, you'll get a different circle that's maybe in a different place, right? Those are different sectarian extensions. If you take the set of all of those for, a restricted class of permissible vectors of interpretations, right? You get this larger kind of shape, sort of like set of extensions or a set of sets or something like that. You might call that an ecumenical or extension or something like that. But yeah, you would want to, in the clear case, distinguish between the sort of like first order extensions and the set of first order extensions.
You presented parameterization as an alternative to sectarian sharpening.
Mm-hmm.
So two competing modelings of the same phenomenon. I'm not that sure. When Alston introduced the notion of combinatorial or multidimensional vagueness, in addition to theoretical vagueness, he described it as the indeterminacy as to just what combination of conditions are sufficient necessary for the application of the term. Now, in many cases, degree vagueness and combinatorial vagueness overlap. Standard examples of combinatorial vagueness, such as religion, also exhibit theoretical vagueness along one or more of its dimensions. Now, I think this is why, in many cases, vagueness of degree remains after you have parameterized concept. And so it seems that sharpening and parameterization do not. These are not two competing modelings of the same phenomenon.
Mm-hmm. Well, I mean, it depends on how you figure distinctness, right? So I started by saying this is a largely methodological talk, so what I'm describing is a particular style of representation, right? And if your standard is what's a style of representation, then I think a parameterized explication is quite different from a collection of sectarian explications. Now, it could be that, like, on further examination, a set of sectarian explications is not inconsistent with or in necessary ontological tension with a parameterized explication, and that's fine. I think that's often going to be true, that these things don't have to be in tension. But if you've got a bunch of sectarian explications, you could do some further very academic work tracing out like what is similar between them and what are the common factors and how do you represent the variety there. But by then you've sort of accomplished an additional intellectual feat on top of having a list of sectarian explications. So given that this is, as I imagine it anyway, methodological talk about a particular style of representation, I would be tempted to say that there is a difference. On the other hand, epistemic humility demands that I be clear, like, I'm not reinventing the wheel here. It's not like this is totally new from anything that anybody's ever suggested before. That's perfectly right as well.
Okay. Thank you.
you. That was great. I was struck by the parallels with a debate in philosophy of language and linguistics about word meaning and whether word meanings are concepts, for instance. And one thing that occurred to me is that it seems like in that debate you could have defended views to very like your vague view, sectarian view, and I think like your view, which might be the view that word meanings are characters, functions from indices to extensions, perhaps. And they also defended a fourth view, I think, which is that word meanings don't determine anything that precise, they just impose some constraints on concepts you can express by that word. I was wondering whether your view is, well, whether I might think that your view is more like the character view and this is a distinct view, or whether your view is something more like it doesn't determine anything that precise, but you impose some constraints, or whether it's too distinct, or whether, so that's the...
Yeah, this could lead into some weird woolly territory. Like, I want to say, like, I have no official answer. So I'm leery of some of the debates about meaning. I mean, I like the idea of meaning, but I don't know what I think about it, and I think people talk past each other when they use that word. So I try to avoid it here. There are some similarities between bits and pieces of this and that, but I mean, my own, I don't have a defense for this ready to go, but my own inclination is to treat this kind of work, and a lot of what philosophers do, that's a controversial statement, as a kind of special logical anthropology or something like that. So I think of these as sort of anthropological methods suitable for the kinds of projects that are interesting to philosophers, without necessarily saying anything. I don't necessarily want to say anything about what meanings really are, what the deep, true structure of a concept is. I'm interested in human practice and ways of describing it, which is in part why I'm, happy for there to be pluralism about this. There are going to be any number of perfectly fine ways of describing a complex phenomenon, even though they might appear at first glance to be in tension. They may not be on further examination, and I don't know. I'm okay with that. I'm happy to get along with people.
So I think my question kind of follows up on Adrian's question. It's a similar question. But maybe approached a little bit differently. So I was thinking. So I think there definitely are kind of concepts that should be modeled in your way, where you're suggesting parameters. But I wonder whether sort of Venn diagrams really capture that. So it's a useful way of kind of visualizing that. So I was thinking when I think parameterization, I think in terms of dimensions in Euclidean space. I think that's the most, for me, that's the most useful way of visualizing that. So you have one parameter is one dimension, and so then something with three parameters would have a three-dimensional thing, and so to model these concepts, you have a blob in that kind of space, for example, a three-dimensional one, and that seems to be more useful than a Venn diagram precisely because you have these parameters that can take on different values as opposed to just being an on and off kind of thing. Do you think that's right, or do you think that sort of addresses these issues?
Yeah, that's fine. I mean, I use these diagrams in talks, and I don't use them when I write. So they're mostly there because I find they get the point across quickly without a lot of commentary. Yeah, I mean, of course, a sort of multi-dimensional space. I mean, it's difficult to represent it visually if you've got more than 3 dimensions, but a multi-dimensional space is a way of sort of describing the space of possible extensions, right? Except I would depart from something like Peter Godfrey Smith's model in his book on Darwinian populations somewhat, in that there's no requirement on parameters as I imagine them that they be that you can characterize them in terms of some single dimension of continuous variation, right? They're not all going to be spectra. So the graphs that you come up with might be, blockier graphs rather than graphs with continuous dimensions, right?
Okay, one question.
Thanks for a very nice talk. It seems to be a feature of some concepts that they sort of resist parameterization. Like many people might feel that about truth or about concepts of morality. And your uncle might well feel that about marriage. Do you think that your picture can sort of model concepts of which it seems to be a sort of essential feature of them that they don't permit parameterization.
So if I understand the intuition you're suggesting is that, like, look, for some concepts, there's a right way to do the drawing and there's a wrong way to do the drawing, and like, well,
yeah. So,
yeah.
so for some concepts, if you start talking about
right.
Multiple options in this sense, then you've missed the point.
Yeah, I would resist that suggestion for boring reasons. The boring reason being that, as I sort of acknowledge, my interest is kind of anthropological. I'm interested in looking at the sort of extant views rather than necessarily characterizing like the true view or whatever. And I think that's going to be the case in a lot of these. Like even talking about cognition or something, a lot of scientists have the intuition that, like, look, there's a thing that's worth meaning by cognition, and there are lots of things that people mean but shouldn't mean by cognition. So the common view is that there's going to be like one relatively classical explication of that concept, like at the end of science or when we do things right. But in the meantime, the discourse is a mess, and I'm interested in a tool for modeling the mess.
I was trying to think of a case in which it's a sort of anthropological fact that built into the discourse is a resistance to parameterization. And I don't think that's true of the scientific cases like cognition, but I think it's at least arguably true of some of the normative cases. And I think your uncle would argue that it was true of marriage.
Okay, with that.
Right. Thank you.
Just to remind the speakers and the chairs that there are vouchers for the lunch available from the registration desk downstairs, and you can go to the restaurant again. If you weren't very happy with the restaurant, I never go to the restaurant, but there are other places where you can have just the sandwich and the
Oh, yeah, sure.
soup, but I don't have vouchers for those other places. Thank you very much. Did you send me that?